Welcome everyone. In this particular session, we are going to discuss about the introduction to big data. Okay. So just before moving forward, what do you mean by big data? We are just thinking like a layman. Okay. What do you mean by big data? Simple definition. The most simple definition can be a data which is in bigger in size. You will refer it as a big data. Okay. So, but what do you mean by bigger in size? What characteristics it should have to call it as a big, why we are calling it as a big. Okay, so this is important. So these are the some of the points with reference to which we are going to discuss about. This is the outline. Yes, a big data overview of different characteristics, definitions, what's driving the data dialogue, drivers for big data, importance for that analytical approach, different data evolutions and rise of big data, and then the number of users, the statistics, what exactly it has. So moving forward, a big data overview. The most simple and most important example that one can consider to think about the big data is our own smartphones that we are using. We daily use it. Even in the settings, we are able to see the time spent, the amount of data that you have consumed per application, per social media application. So generally I can say if you just glance through it, it moves around more than 500 MB around the GB as well. Okay. So for example, any particular user is using the mobile, using the social media content, okay, just surfing to the internet and downloading some of the things, okay, doing the multiple number of actions or the data. So here you can think for a particular user, for a single user, it's around 800 MB or 1 GB. Then you can think the same about 10 users, 100 users, a millions of users and the billions of users. Okay. So here one can think about the seriousness about the big data. So what do you mean by a big data and how it is getting generated? This is a simple example. Okay. There are more number of other ways. There are more number of other inputs. There are more number of other drivers. Okay, which are playing the crucial role in creation of this big data. Okay, devices and the sensors automatically generate the diagnostic information. One more example that you can consider, that is a CCTV. Okay, most of the time we just roam here and there, so we are able to see the CCTVs. So here you can think the CCTVs and the data is getting generated through that particular CCTV. The recording is getting saved. Okay. So one can think about a single CCTV and the number of CCTVs around you, around your area as well. Okay, credit card companies, then the mobile phone companies. Okay, the callings that we are right now we are using a free calling services. The number of calls that we have, how that particular data is getting saved, and most importantly for the social network, for the social media. Data is its own primary product. Okay, we can take one example of like LinkedIn or the Facebook. Okay, so where the data itself is their primary product, so it is getting generated through data we are handling. For example, again I can talk about WhatsApp as well. Okay, what basically we are using the WhatsApp for, a data or the data exchange. Okay, so this is nothing but the overview. So some of the characteristics. Okay, to talk about the characteristics, it's always a volume, variety and the velocity of that data particular. So to talk about the huge volume of data here, rather than thousands or millions of rows, big data can be billions of rows and millions of columns. Yes, exactly. That is what the point of discussion is. Yes, one cannot just say the number of different lines, rows and columns. So here you can talk about the billions of rows and millions of columns together to handle that particular data. Okay, complexity of data types and structures. A big data reflects the variety of new data sources, formats and structures, including digital traces being left on the web and other digital repositories for subsequent analysis. Okay, so importantly, what the complexity of different data types and structures is handling, and the speed of new data creation and the growth. So big data can describe high velocity data with rapid data injection and near real-time analysis. Okay, so just to stick towards some big data characteristics or the V's of big data, you call it as a. So basically we can consider these are the three, like volume, variety, and the velocity. As it suggests, volume, nothing but the size in a bucket in which it is going to fit, that is a volume, the size it carries. A variety of data, that is the different variations in the data. It is not of one format. Okay, there are various formats that it carries. And the velocity, the speed at which it is flowing, and that we need to handle and need to taken care of as well. Okay, so as one can see, a big data characteristics and a different number of types it has. That is nothing but structured, semi-structured, and the unstructured. Generally we think it as a structured, semi-structured, and the unstructured, but in between that semi-structured and unstructured, one more structure is hiding, that is we are calling it as a quasi-structured data. Okay, so what do you mean by quasi-structure? Here one can say it's more of a textual data with some erratic data formats. Means what? We can just take some efforts and we can just format that data by using some tools, taking some time. Okay, so most of the time that clickstream data, particularly we have kind of a Google searches, okay, that falls under the category that is called as quasi-structure. Okay, so these are the basic main three parts: structured, semi-structured, and the unstructured. So here we can just see some of the basic examples for structured, semi-structured, and unstructured. Structured data is what? A defined data type, format, structured transactional data, OLAP cubes, a relational database management system, okay, and spreadsheets which are in a proper format, one can say, that we call it as a structured. Semi-structured, a text data with discriminable patterns, that is XML files, JSON files, HTML, or the log files, that neither falls in structured nor falls in the unstructured part. Okay, unstructured data with no inherent structure, for example text docs or the PDFs or the image or the video. Okay, either for being the image or the video, we are able to identify the things, we are going to get the message what it talks about, but for the system it is again a kind of unstructured data. Okay, whenever we talk about some ML techniques, okay, latest techniques, we talk about handling the image data, handling the audio, handling the video data, okay, as per the system is considered. So these are the structured, semi-structured, and the unstructured. These are the basic structures that falls whenever I'm talking about the big data as input to the system. So this is one of the basic example again, a data containing a defined type, format, and structure, that is transaction data, online analytical processing, data cubes, the relational database management system. In simple words, you can say the data which is in the form of rows and columns and which is usable, okay, which carries some semantics, which carries some information for you, which carries some structured content for you, that you call it as that you refer as a structured data. Okay, now the semi-structured data, a textual data, here you can say with a discriminable patterns that enables parsing such as XML data. Okay, as you can see the example in the image displayed. Okay, if you are just moving toward the source of any web page, you are able to see the code, you are able to see the data. Okay, that is nothing but what? That is a self-describing and defined by the XML schema. Some other example like HTML or the JSON files or the log files, that falls under the category semi-structured data. Now unstructured data, again data that has no inherent structure, which may include text, documents, PDFs, images, and video. Okay, so that has no inherent structure. So the rock, simply one can call it as a rock. Okay, so what does it mean rock? In the sense, it means that that particular data is not passing any information to you. Okay, you are neither able to just get some semantics out of it, some patterns out of it, some data out of it, that you call it as unstructured data. Okay, so the basic examples are PDFs, images, and the videos. Okay, I mentioned as being a layman, you may be able to find something from the image, you may be able to rectify, you may be able to understand the messages from images and videos, but for the system it falls under the category unstructured data when you need to work on that particular data. Okay, yes, so talking about the definition of big data, There are so many definitions which can just talk about the big data, but I'm just sticking to the one of the standard definition, okay, which is coming from the McKinsey Global Report from 2011. That is, a big data is a data whole scale, distribution, diversity, and or timeliness require the use of new technical architectures and analytics to enable the insights that unlock new sources of business value. So what does it mean? Basically it means that yes, big data is nothing but it's a distribution, it's a data, but after having a work on it or after thinking on it, after just going through some processes, what it should do, it should just increase your business value, okay, or it should at least give you the analytics to enable the insights that can unlock some of the new sources for your business value. Yes, this is what the standard definition of big data. So what's driving the data deluge? As you can see in the right side, the mobile sensors, social media, video surveillance, video rendering, smart grids, and all other things. So mobile sensors, here you can call about the GPS, the accelerometers. Social media, we already seen the number of different applications that we are using, a huge amount of data. Then the video surveillance, street cameras on the stores, a video rendering, processing for videos for the display. Then smart grids, gathering and the act of the information. Geophysical exploration, that is for oils and gases. A medical imaging, this is again the hot topic, okay. As of now, if you are talking about the IoT, you are talking about the role of technology in medical field. Yes, it's producing huge amount of data. Then the gene sequencing, so it's more prevalent, less expensive. Healthcare would like to predict a personal illness, okay. So as you are talking about this all personalized thing with respect to IoT as well, okay, these are nothing but the drivers for big data. So these are the standard drivers that we are just seeing. These bold points, that is a medical information, photos and videos, mobile services, mobile devices, smart devices, and non-traditional IT devices. So what does it mean? Medical information, as we already discussed, role of technology in medical field, producing the data, photos and videos. We have seen through the number of footages. Here you can see the image processing, training and testing the data sets. Videos, talking about CCTVs and footage. Mobile devices, we already discussed about the users using the mobile, using surfing to the internet, going to the number of different apps. Smart devices, here you can call about some IoT devices, okay, sensor based, where you are able to see a different number of huge amount of data is getting explored or the created. Non-traditional IT devices, here you can think of a radio frequency identification, that is RFID readers, GPS navigation systems, and seismic processing. Okay, so these are some of the basic drivers for big data. One can I'm just intentionally adding this point as a business drivers for advanced analytics. Okay, we have seen some basic drivers. So here business drivers, optimizing business operations, which will affect examples for sales, pricing, the profitability and efficiency. Okay, a business driver, identifying the business risk. Yes, here you can think about example like a customer churn, okay, the behavior of a customer with respect to particular product or the service, okay, fraud and all other things. Talking about predicting new business opportunities, here you can say about upsell, a cross sell, a best new customer prospects. Talking about a business driver complying with laws and regulatory requirements, the standard example that you can call about anti-money laundering, okay, a fair lending, and Basel 2 and 3 and Sarbanes-Oxley. Okay, so what does it stand for? It's nothing but one of the act that was established for shaping some auditions and financial regulations for public companies. Okay, I'm talking about these business drivers for advanced analytics. Okay, these are some a step ahead rather than the basic drivers for the big data. So importance of analytical approach for big data, it is a cost saving, time reductions, new product development, understanding the market conditions, and controlling online reputation. So why this analytical approach is important to handle the big data? This is the important thing. First thing is cost saving, okay, helping in identifying more efficient ways of doing the business. So it will surely save your cost, okay. Second one, time reductions, help businesses analyzing data immediately and make quick decisions. As you have seen, same in the definition of big data, it should give some insights to your business value. Okay. Third one, the new product development. By knowing the trends of customer needs and satisfaction through the analytics, you can create products according to the wants of the customer. So that is a new product development. Understanding the market conditions. By analyzing big data, you can get a better understanding of current market conditions. And last one is controlling online reputation. So big data tools can do sentiment analysis, and therefore you can get feedback about who is saying what about your company. Okay, so these are some of the importance of analytical approach. A data evolution and the rise of big data. As you can see, there are 3 pages. Phase 1 talking about structured content, that is from 1970 to 2000. Phase 2 talking about web-based unstructured content from the period of 2000 to 2010. And big data phase 3 talking about mobile and sensor based content from the period of 2010 to the current one. Okay, so earlier in the phase 1 we are talking about RDBMS, or the data warehousing, the basic ETL process, that is extract, transform and load, online analytical processing. Okay, these are some of the points we are thinking as a phase 1 structured data. In the phase 2, information retrieval, opinion mining. Okay, it is going a step ahead. Question answering, social media analytics, okay, web analytics and the web intelligence. And the evolution coming right now, that is talking about mobile and sensor based content. Here the location aware analysis, a person centered analysis that we have seen, a person to person data is getting monitored, data is getting saved in the system. Okay, so these are some of the, this is a visualizations for the data evolution and the rise of big data, right from phase 1 to phase 3. Okay, and just the second last slide for the main discussion, because we are just discussing the basics of big data here. So here these are the latest statistics, that is from April 2024, and this is nothing but each day use of internet from the age group 16 to 64. Okay, so you can see here the time spent using internet, it is 6 hours 35 minutes. Then time spent watching the television, 3 hours 8 minutes. Time spent using social media, 2 hours 20 minutes. Reading some press media online, 1 hour 39 minutes. Time spent listening to the music streamings, that is 1 hour 24 minutes. Listening to the broadcast radio, 49 minutes. Time spent for a podcast, that is around 48 minutes. And a time spent using a game console, it is around 1 hour. So you can think about the age group from 16 to 64 per day just consuming this amount of data, or this much amount of data. Okay, so how much difficult is that to maintain or to just deal with this data? Okay, the main intention of behind this discussion is that you should just able to think what do you mean by big data. You should be curious, you should be thinking of what's next. Okay, so discussion can be continued, so you can think about the big data, what is the architecture of it, different approaches to handle it, then what you can think about number of tools, techniques, all the platforms that are available. Okay, then the number of huge amount of data is there, so the need of storing and handling the data as per the requirement, different requirements one can think of, different ecosystems of big data. Okay, what does it provide to you? Cloud storage, what do you mean by cloud storage, how one can relate it to big data? Yes, is there any connection in between it? And the most importantly, big data concern with artificial intelligence, machine learning, data science, kind of edge cutting latest technologies, or you can say these as a hot topics of this current era of technology. Okay, so how that big data deals with all these things. Okay, so in the next session we can think a step ahead to this discussion. So I hope this discussion just you are getting the insight of what do you mean by big data and what is the characteristics out of it. Okay, thank you everyone.